Hi everyone, welcome to another session of the HBL files. In today's session, we will be discussing about projectile motion. Let's begin with this object located at this position at time is equal to 0. We then make this assumption that only the acceleration due to gravity is affecting this object and nothing else. We then give this object an initial velocity to this direction. After 1 second, the object has traveled this distance. After another second, the same additional distance was covered. 3 seconds, 4, 5 seconds, 6, 7, and then 8. Notice that equal distances were traveled by the object for equal time intervals. This is the case because the acceleration due to gravity is not acting along the horizontal. This means that there's no acceleration along the x direction. And the initial velocity at this position will be equal to the final velocity of the object at this position. Next. We again consider the same object at this position at time is equal to 0. Again, we keep in mind the assumption that we made in the previous part, that only the acceleration due to gravity will be affecting the object. We then give this object an initial velocity directed vertically upwards. After 1 second, the object traveled this distance, 2 seconds, 3 seconds, and then at 4 seconds, the object reaches its maximum height. Notice that the additional distances covered by the object for equal time intervals were different. The distances were different, or the heights were different. Why? Remember that the acceleration due to gravity is acting along the vertical direction. And in this case, the acceleration due to gravity is of course directed down. Notice that the acceleration directed down and the velocity is directed up. They are in opposite directions. When velocity and acceleration are in opposite directions, the object slows down. And that's the reason why the additional distances covered by the object won't be equal. Now, at 4 seconds, the object reaches its maximum height. At that position, the object becomes momentarily at rest, meaning the velocity at that point will be equal to 0. But the object will soon start moving since it is affected by the downward acceleration. This time, the object is now moving going down, or is now moving downwards. That means the velocity is directed down. At 5 seconds and at 6 seconds, these are the relative positions. At 7 seconds, and finally, at 8 seconds, it returns to its original elevation. Now, why is it that as the object goes down, the additional distances covered were increasing? Remember that the acceleration is directed down. And on this part of the motion, the velocity is also directed down. Since velocity and acceleration are in the same directions, that means the object speeds up. And as it speeds up, greater vertical distances were covered for the same time intervals. Again, for this scenario, we have the acceleration to be equal to the acceleration due to gravity. And notice that the initial and final velocities are actually equal. in terms of magnitude, but are in opposite directions. Why? Remember that the same acceleration due to gravity was affecting the upward and downward movement of the object, which means that if from 0 to 1 second, the velocity decreased by 5 meters per second, for the corresponding 7 to 8 second time interval, the velocity increases by 5 meters per second. So whatever the decrease in the velocity of the object from 1 to 2 seconds, that will be the same increase to the velocity from 6 to 7 seconds. Now, let us combine the horizontal and vertical motions that we have just discussed. Remember that in both motions, I mentioned the assumption that only the acceleration due to gravity will be affecting the object. So this is the horizontal motion. And this is the first part of the vertical motion when the object is going up. Notice that the initial positions in both motions were the same. Next, this is the second part of the vertical motion. That is when the object is going down. And again, the positions of the objects in the two motions were the same for this same time interval or same time, 8 seconds. Now, let us mark the positions indicated by the X or by the horizontal and vertical motions for the same times. At 0 second, the object is located here, as indicated by the green circle. At 1 second, this is the position according to the horizontal motion. According to the vertical motion, the object is around here. That means our object will be at this position. Following the same pattern for 2 seconds, we have this one. 3 seconds, 4, 5 seconds, 6, 7, and then finally 8. We then trace the path of this green object over here. And notice the path to be a curved path or a parabolic path. Now, this is an example of an object undergoing projectile motion. The object that was projected in air is what we call as the projectile, while the path taken by the object is what we call as the trajectory. Now, again, this object, the green object, is like an object that's projected at a certain angle. That means this object will have both vertical and horizontal initial velocities. Now, notice that as this object travels its path, okay, the corresponding horizontal component of its motion will be like this. Again, this is possible because along the horizontal, there is no acceleration. So whatever this initial velocity along the horizontal of this green object is at the beginning, that will be the same velocity along the horizontal that will be applied all throughout the motion of this object. Now, let's look at the vertical component. So again, we have here this green object given the same initial velocity that's projected at a certain angle. So this velocity will have both x and y components. This time, we look at the y components or the vertical components of the motion of this green object. Notice that although the object was projected at a certain angle, its y component of motion or the vertical motion for this object is actually similar to an object that's just, thrown vertically upwards. So again, here in this discussion, we have seen that projectile motion is actually a combination of horizontal and vertical motion happening at the same time. But on the other hand, we can also say that the horizontal and vertical motions are independent of each other. We can solve the vertical component first or the horizontal component of the object undergoing projectile motion. Now, this allows our analysis of the projectile motion to be a bit simpler since we can separate the horizontal and vertical motions from each other. Okay, so that's it. I hope everything's clear. Thank you for learning with me today, guys, and see you on the next session of the HPL files.